In this example, we'll be adding or subtracting the following fractions. Now, a key point for adding and subtracting fractions is that the denominator needs to be the same. That's the bottom number. The reason why that is because a fraction is part of a whole, and the bottom number is how many equal pieces the whole is divided into. So a denominator of 4 would mean something divided up into 4 equal sections. When you're adding or subtracting fractions, you need to compare shapes that are divided by the same amount so that the slices are the same amount. So this first one, we've got 2/3 plus 5/3. We have a common denominator. We know that the denominator will stay. It'll be 3. When we add or subtract pieces of a pie, the size of the pieces doesn't change. So if it's division by 4 here, the bottom part of the fraction is 4, those pieces have to be the same and they'll remain the same. What will change is how many pieces we have, which is the part on the top, the part that you have. So if I shaded just one in, that would be 1 of 4 pieces. Here we have 2 of 3 and 5 of 3, and we need to add those pieces together. So we add the numerators together. 2 plus 5 is 7. If we can divide the numerator and the denominator by the same number evenly, then we should. In this case, though, 3 and 7 are both prime numbers, and neither one shares any factors other than 1 in common, and so we're good. With b, we have 4/5 minus 3/5. The denominator is the same, so we'll keep that denominator. 4 minus 3 is 1. And that's it, really. So once you have the understanding when you add or subtract fractions that you need a common denominator, it becomes fairly easy. Here, though, in C and also in D, we have fractions that don't have common denominators. So what we need to do is we need to multiply each fraction by 1, and we'll pick and choose for each one what 1 is going to look like to be able to get a common denominator. You're looking really for the least common denominator, but in a pinch you can just multiply the denominators together, and that's the new number that you're looking for right here. In this case, it happens to be the least common denominator as well. Sometimes that'll be the least common denominator, sometimes not, but it always works. So we need to figure out what to multiply 5 by to get 10, and that's 2. And if we multiply the bottom by 2, we need to multiply the top by 2. If we don't, then we're changing the amount that we have. In other words, 2/5 is not the same as 2/10. 2/10 is a lot lower. However, 2 times 2 is 4, and 4 over 10. Well, that would work, right? If you had 2/5 of a dollar, you'd have 40 cents, and if you had 4/10 of a dollar, you'd still have 40 cents. So we haven't changed the value of 2/5, we've just changed the way that it looks. With 3 over 2, we need to do the same thing, but this time we're going to multiply the bottom by 5, and we must also multiply the top or the numerator by 5. 3 times 5 is 15. 2 times 5 is our 10. We can now actually perform this operation. 4 minus 15 is negative 11 over 10. I like to put the negative sign out front of the fraction bar because actually it could belong in either one. We have a number minus a larger negative number, and so the total value is negative itself. And if this was negative 11 divided by positive 10, you'd be good to go, or positive 11 divided by negative 10. So when there's one negative sign, that negative sign is usually written out front. It could belong with either the top or the bottom, as long as the other part of the fraction is positive. So the negative sign would go here, positive down below, or positive 11, negative 10 on the bottom. This is fine. You could change this into a mixed number if you wanted to, but this improper fraction is okay. It's a lot better for algebra actually to use an improper fraction. And then of course if your answer was like, how much money you lost or something, then it would be $1.10 is what you lost. So you can change it into decimal or mixed number if you want. In part D, we've got 1 over 4 plus 3 over 8. We could multiply these two together, but it's not the least common denominator. So if you can't see that right off the bat, it's okay to multiply 8 times 4, and that'll be your new denominator. But in this case, I'm noticing that if we just multiply the bottom by 2, we will have a common denominator. So we actually don't have to mess around with this other one. So 1 times 2 is 2, 4 times 2 is 8, and then we've got 3 over 8. Didn't have to do anything to the right fraction. Remember that we're not changing the value of 1/4. If you had a pie and you wanted one slice and there were 4 slices in total in the entire pie, pretty big slices, and you just wanted one, then 1/4 would represent that. If you split those pieces of pie up into 8 slices and you still wanted 1/4 of the pie, you'd need 2 of those 2 of those slices when the whole is divided up into 8 pieces, and that would actually be the same amount. You'd still have 1/4. Anyway, 2 plus 3 is 5, and then we remember that we need to keep the denominator because when you compare pieces, in this case the size of the piece doesn't change. Just how many you have will change.